if you have it somewhere.
Yeah, let me just, I'll make a note to myself. Yeah, we did go over this stuff, and I'm pretty sure that it is.
Yeah, because I noticed some of the stuff that was later on that agenda, I was there for, so I was like, oh, I just missed those.
Okay, yeah. Let me see if it's the more recent office hours. I try to put in the description. Understanding man page synopsis now. 6/29, that's a month ago. Ah, these are in the opposite order. 7/17, it's probably this one. Okay, if it's not this one, then I will find it. Yeah, okay, I'll find them and upload them. I will find it and upload it after this, or find where I did upload it if it's already there, and I'll let you know. So that's these next three, I think.
Yeah.
And then when would I choose Mongo versus SQL? Whose question was that?
Oh, that was mine too.
Cool. So that's a good question. It's a big question. Let's see where to start with this one. So let me go back first and just talk about like traditional SQL databases. So like Postgres, MySQL, Microsoft SQL Server. So all of these databases have these guarantees. They're called ACID compliance. So ACID stands for atomic, consistent, can't spell it. Consistent, where is it? ACID. Oh, that's really vague. And there it is. Durability. Okay. So when people are talking about an SQL database versus like a Mongo or some other sort of like document store, usually what they're talking about is the fact that SQL databases provide these guarantees. So atomicity means that I can package up some changes in an atomic transaction, and either they all happen or none of them happen. So a good example of this is doing a like checking account transaction where I'm going to like transfer money from your account to my account. So I need to decrement the total number of dollars in your account, and then I need to add to the total number of dollars in my account, and I need those two operations to be atomic, so that either they're both going to happen or neither of them are going to happen. But if lightning hits the data center in the middle of that transaction, I don't want to debit your account without crediting my account, right? Otherwise, the money is just lost forever. It doesn't, you know, that it needs to go somewhere. And so that's one guarantee that traditional SQL databases give you. They allow you to do atomic transactions and sort of group together different statements. So in that case, that would be like two update statements in SQL. You can group those together and say, okay, these two things are one thing. They either both happen or neither of them happen. There's never a state of the database where only one has happened and the other hasn't. You can sort of group things together that way. And that's actually, it's a lot of work to make that happen, right? The database is basically writing down a plan of like, here's the transactions I'm about to try and do, so that if the lightning hits the data center, when the database comes back up, it can go back and look at its logs and say, oh, okay, I was halfway through this transaction, but I didn't finish it, so I'm going to go back and roll back the first part of it. since something bad happened. And consistency, isolation, durability. Isolation just means that like if I have like multiple transactions happening at the same time, they're isolated from each other, so that like one transaction that's in progress isn't seeing data that has been changed by the first steps in another transaction that hasn't completed. So for instance, if that sort of like debit your account, credit my account transaction is happening, if there are other read operations happening at the database, on the database, those read operations aren't going to see your account value go up until that whole transaction is completed. And durability is sort of the same thing. Like once the database says, yeah, I've written, once you get a successful response from like a database insert, for example, if the database says, yeah, I just inserted that for you. Durability means, again, if lightning hits the data center or if the server crashes or whatever, your data is safe. It has been written to disk. It's somewhere durable. If the database program crashes, you're not going to lose any data. So these are like really important attributes to have for a database, but they're very expensive to implement, and they make the database slower, or they can. This is not to say that traditional relational databases, which is what people usually mean when they say SQL database, doesn't mean that those databases are slow. You can scale those things pretty well. However, they are doing some extra work to guarantee these types of things. What happens in some cases is, so why would you use Mongo instead of one of these relational databases? So the reason you use Mongo is because you want something else even more than the promise that your data is going to be there once it's been written, right? So one example, so Mongo lets go of some of these constraints. So for example, durability. You can configure your Mongo writes and say, yeah, I don't actually care if this transaction has like really been written to disk, just as long as the database knows about it and is gonna try to write it to disk eventually, then like that's great for me. I'm not gonna wait around for you to tell me that like the data has been like really durably stored. For banking transactions, that would be an awful idea, right? Like, yes, we want to make sure before telling someone they have this money that the transaction like actually completed. But if what you're writing is events, right? You're recording every time somebody clicks on your website or every mouse movement. So you have like tons and tons of data. If you lose a little bit of it, it's not that big of a deal. You just want to be able to store it as fast as possible. So Mongo allows you to kind of tune the durability and the consistency to say, yeah, just like write all this stuff, just write it in memory for now, and then every few seconds go and like flush it all out to disk. And you can write to tables that way. And it makes writing to the tables way faster, because it's a lot faster just to put stuff in memory than write it to disk. But you lose that durability constraint. So it's a trade-off you're making. So a lot of times Mongo will be used to like for like log files or like trace data. So that's one reason you might want to use Mongo versus SQL. Another reason might be that you have your Facebook or something, right? You have this massive website with massive amounts of data, and you just can't get a traditional relational database to scale to the size that you need it to. Because one of the main constraints of traditional relational SQL databases is that to get these guarantees, they're generally running on a single server. So if you need a faster database or bigger database, you have to buy bigger hardware. They don't tend to run as well on like virtual machines and like, cloud instances. When you really need to scale them, eventually you're going to need like a dedicated server somewhere, like a physical dedicated server. And so they can be either expensive to scale or hard to scale. And this is usually called scaling vertically, like when you're scaling your database by just getting a bigger and bigger server. It's like vertical scaling. The other way you could scale something, right, is to use like 100 smaller servers working together, but it's really hard to guarantee these sorts of transactions and durability when you have 100 different servers communicating. There's like way more chaos. And Mongo is built to work very well scaling horizontally, adding more and more servers, and sort of you send a write to the cluster and you'll get a notification back once that write has made it out to 10 of your 100 servers or some number. But at that point, you're sort of losing this consistency that like, well, the data on one of your Mongo instances is a little different than the data on your other Mongo instance. Eventually, it's going to be consistent. Eventually, all of the copies of your database will say the same thing, but there's this moment in time where data is propagating out and it's different depending on which node of the cluster you hit. And again, so it's a trade-off where you're giving up consistency for this massive scalability, which you may want in some cases, or you may not. So, and again, this is a deep topic, and there are probably people out there that know a lot more about it than I do. I did do a little work as a database administrator for a while. I went to some Mongo conferences and some SQL conferences, and I did a bit of research into it. But that's the basic idea, is why you would choose one or the other. I guess so. The other thing I'll mention is that Mongo stores things as documents. So with SQL, you have like rows and columns. So you have this in most SQL databases, you have to specify the schema of your table. So your table has 4 columns and 3 of them are integers and one of them is a string. And so every row in the column has to have those attributes, have to be the same type. Mongo is a document data store, which means you can basically store like a JSON blob. Basically anything you could represent as a JSON object, you could store as a record in a Mongo table. And the records in a table in Mongo can all be completely different. They don't have to have the same keys. They don't have to have the same structure. You don't have to define the schema ahead of time. You can just start adding stuff into a Mongo record in some table without like a schema change. So it's very flexible in that sense. Again, there's some other trade-offs you're making for that. But it can be like really nice to develop against, because instead of like when you find out like, oh, users are going to have a street address now and you want to add that attribute to your users table, with SQL, you have to do a migration. You have to like add that column to your schema. With Mongo, the database doesn't have to change at all. You can just start saving extra attributes with your users and things will just work. And so it can feel a lot easier to develop against, and there's a lot of flexibility in that. But you're losing the ability to do some of the kind of joining that you can do in SQL, where you're sort of joining one table with another and doing efficient queries that way. In a document-oriented database, a lot of times, if you want to query multiple tables in conjunction, there's not like an easy way to do that in one query. You end up having to do multiple queries. So does that answer some of your question?
Yeah, that was a pretty good answer.
Okay, cool. Let's see. So what else do we want to talk about? Anyone? My chat open here. Anybody thinking of doing the phase 3 interview soon-ish?
Yeah, I'm thinking about doing it. So,
yeah. Very cool. We have a bunch of people doing the phase 2 interview this week. So phase 2 could get dramatically bigger suddenly on Monday.
Can I ask you questions about it? Or
about the phase 3 interview?
Yeah.
Sure. Mm-hmm.
Okay. What was the one that I had? Okay, database.test. Okay. So in one of the challenges, I just wanted to just get another perspective on how you would just write a test for a database without creating any routes.
Say that last sentence again, without doing what?
Without creating routes. So if I just wanted to test the database query using Mocha and Chai, what are some ways that you use to do that? I've seen somebody use like a return of the query, and then they use, I think, a .then or something like that.
Right. So yeah, if you just wanted to test a database query, so yeah, I mean, is the question, so what specifically about that are you wondering, I guess? I'm not sure.
Just the syntax for how you would test it in Mocha and Chai, using Mocha and Chai, like how you would write the request response with the, what you call it, with the expect or assert, like how you would structure that.
Like, okay.
Because I can console log and get the query that I want, but in order to run it through a test, I get errors.
Okay. Do you have some code that we could look at?
I do actually.
You want to?
Go to EOBar on GitHub.
Okay. Let's hope that GitHub's back up. Come on, GitHub. Be the ball.
/EOBAAH. Yep. And then you go to.
Sorry, I couldn't find a repository. EOBAAH.
Yeah.
There.
Just put it up, yeah, in the URL. Yep. Perfect. And if you go click on the repos at the top. Yep. And phase 3 practice.
There we go. Awesome.
Part 2. So yeah. So yeah.
Okay.
So this is what I had to do in order to get my tests to pass. I had to create routes and then test the routes. But I know there's a way just to test just directly from the database.
I see. Okay. So you have methods in here. Okay. So you want to be able to test a method like this.
Exactly.
Yeah. Okay. Yeah, that's doable. So many, and you're using PG promise?
Yeah.
Okay, so these methods return promises. So what the more general thing that you need to do here is just test a method that returns a promise, right? And in that case, there's just a couple ways to do that. One would be, let's say I've got and then okay, so say you've got your method that you want to test here. Let's call it cheap items, right? So you're testing cheap items, right? And you know that this thing returns a promise. So when I call cheap items, I'm going to get this promise back.
Yep.
So to test the return value of that promise, and this is Mocha, so I've got this done going on here. I'm going to say p.then, right? So once I get the result, then write your tests in a .then callback. So now I can say expect result to have 10 items, or whatever it is, whatever assertion you want to make on result. If you put it in the then, and then you can just test like normal, right? So you'll have the resolved result of whatever cheap items returned, right, from the promise. And then just don't forget to call done here when you're done to tell Mocha that you're done. Does that make sense?
Yeah, I tried that and it didn't work for me.
Okay.
So yeah, I tried, and then I think I remember seeing Jared doing something where he had a return. He actually returned on line 3.
Right. Yes. So that's the other way you can do this. So Mocha gives you this done function to call, or you can ignore the done and just return a promise from your tests. So you can actually return here. Because remember, p dot then returns a promise that will return like when this code gets resolved. So you could shorten all of this, and since we're just storing that promise in a variable here, you could shorten all of this to something like this.
Yeah.
Items then.
And then put the return there. Exactly. Okay.
So that should work for you. If that didn't work, it may have been like a syntax thing.
Okay.
Taking the promise, but that's the direction you want to go in for sure.
Okay.
There's a library called chai as promised. That sort of is a mix into chai, and that gives you a slightly nicer syntax for this, where instead of having to say dot then and put the expect down in the result, another way to do that with chai as promised, you can say, you still have to return, but then you can say expect cheap items. Right, so you can get the result, and then say to eventually equal some array, right, or some whatever. You can sort of say, you can say expect to eventually, and then chain on any other expectations like you would normally use. And this whole expectation will sort of like take this promise, wait for it to resolve, and then run the expectation on whatever it resolves to. And so that's kind of handy. It's also nice for testing when things are supposed to fail. So if you have a situation where you're expecting cheap items to throw an error or the promise to be rejected, you can say to eventually, or you can say to be rejected, I think is the syntax, to test the case where it doesn't resolve to anything. So you can look at the docs for chai as promised, which might give you like a slightly nicer syntax for doing the same thing.
Okay.
But this is the basic idea here. It's just like when you're testing an asynchronous function, you just have to put the expectations down in the dot then in the callback, and then just return the promise, or remember to call done in the callback, depending on which way you prefer to do it.
Why is it necessary to put the done there?
So if we don't put the done, if we don't return the promise, and we don't call done here, what happens is Mocha comes through and it sees, oh, you want to run this test called works, and the test is this function. And so it'll run this code, and this function will call cheap items, right? And then register this callback on the promise, right? Say, oh, when there's a result, then run this expectation. And then it'll return immediately, right? And so as far as Mocha knows, this test is, it doesn't know that your test is done, right? Because this function is going to return immediately. And then the database is going to start churning and finding cheap items for you. And Mocha doesn't know how long to wait. So it doesn't know that you've registered this code that's going to like fire when cheap items is finished. So it will just wait indefinitely until it hits some timeout. And so calling done is the way you tell Mocha, okay, I've actually run my expectations now. Because what could happen is that cheap items never resolves, right? The database just hangs forever, and your code here never gets called. And Mocha doesn't know the difference between expectations that passed and expectations that were never reached. The way it knows that an expectation failed is that an error is thrown. But if you never actually hit this line at all, then it doesn't know that a test was missed. So you need to call done to let it know that like, okay, all the expectations that I wanted to execute have been executed. Now you can move on to the next test. Does that make sense? Kind of needs to know when it can move on to the next test because all of your asynchronous stuff that happened in this test is finished.
And in this case, I don't have to put done as a parameter in line 4.
You do. Sorry.
You do. Okay. Okay.
Yeah.
Awesome.
Yeah. So you either have to put done as a parameter and call it after your expectations, or don't put it as a parameter and actually just return the promise here. And in that case, Mocha will just like take that promise and it will register its own .then on it. Basically, it'll wait for it to resolve, and that's how it'll know that your tests are complete. Make sense?
I'm gonna redo it and try it. Thank you.
Okay. It can be a little tricky the first time. But that's the direction you want to go in. Cool. How are we doing for time? We got 10 minutes. Anything else? Other questions?
This is a little like, I don't know, tangential, but do you know if there's any like GitHub alternatives that let you organize your stuff into folders or anything like that?
Oh, let you organize like your repositories into folders?
Or like some sort of categories?
That's a good question. I think that GitHub might allow you to, let me go to mine. I think you might be able to tag repositories. Let me see if that's a thing, type all. I gotcha. So it lets you filter by language and type, but that's about it. Let's see. Yeah, no, unfortunately, I'm not sure if there are other tools that allow you to do that. I know, Bitbucket is one that you could look at, which is kind of a competitor to GitHub. Let's see. That's still a thing, right? I'm not sure what all the free version gets you, but that's another option. But you can. So what I typically do is, I have all my repositories checked out locally, and I organize them in folders locally. So just because they're all sort of at one level in GitHub doesn't mean you can't like organize them in your file system in a more sane way and like put things in folders. But yeah, unfortunately, I don't know. I don't know an alternative to GitHub.
It's okay. I was just curious because I noticed that like if I'm working on an exercise, I was like feeling a little more self-conscious about putting it up on GitHub, like all the like dumb little exercises, but then I was like, oh, but I still want all the version tracking.
Right. Yeah. So you can do private repos, but I think you got to pay for that with GitHub. I think that's where the paywall starts. Where if you want to post something, you want to upload something that's private, you got to put it there. So what you can do, you don't need GitHub to use Git, right? You can have a repository locally. You can commit to it, track versions, and keep it all local. You never have to Git push anywhere. So you can do that. The only downside of that, of course, is if your hard drive crashes, you lose it. But there's nothing to stop you from, if you use like Dropbox or something like that and have like a Dropbox folder on your computer that like syncs to the cloud that's private. You can go and create a directory in there and Git init right in Dropbox. It's all just files. And so you could have Git repositories that are just local, that are private, but they're in your sort of like Dropbox folder getting synced to your Dropbox so that you don't lose stuff. So they're backed up and available anywhere. Or you can use like Google Drive for that, or any number of like free services.
Okay,
So that might
cool.
be one option. If you want like private stuff, instead of pushing it to GitHub, you could just keep the repo on your file system and just put it somewhere where you know it's getting synced to like your private cloud or something like that.
Okay, cool, thanks.
Yeah, I have one last question, Trevor. Over the weekend, I was looking at the map object, and I've never really used it before. And I was just wondering if you could give me an example of like when is the best time to use it, or when would be an ideal situation?
That's a great question. So,
so just to provide you with context, like when I was doing the phase 3 example, let's say each item in the shopping cart, I would want to, when you click on that item, I would want to store that value somewhere. And so I was trying to find ways to store the item and the price, like as a data set attribute, and then store it as an object, as opposed to creating a data set for price and a data set for item name. And so I was just looking at different ways to basically use that in that example.
Right, yeah. Let me just scan through this. So object is present, you know, he's, all right. Okay, so objects and maps are really similar in JavaScript, right? They're both sort of this, what you might call a dictionary. So let me just drop down to, let's go over here. So, so let's create an object, right? String A holds the number 1 and B holds the number 2. And our map, new map. B2. All right, so now we have got a map and an object that basically hold the same data, right? So you can do, in most cases, objects and maps, you can use them, you can do pretty much the same thing with each of them. The differences between objects and map are going to be things like, say I wanted to map, so with objects, the key names have to be strings or symbols. So I can have, you know, strings that are A and B, but if I wanted to have, if I wanted to create an object, I want to say object 3 equals.
What about if that was a function, like console log 4?
What if there was a function console log?
Yeah, like if I wanted to make a key value pair of C is a function console log 4. So C semicolon as part of object. Could I do that in map?
Yeah. So there's not a restriction on the values of an object, but there is a restriction on the key. So for instance, see, if I tried to set the key 3, the number 3 in the object and set it equal to 4, but what I actually got is the string 3 as the key instead of the number. I can't use an integer, but with map, I can. I can say map set 3, 4. And now you can see in the map, the key is actually the number 3, not the string 3. This gets even more complicated where I can set the key to be an array of values.
Oh, wow.
Right? So the key in a map can be anything, any object. So in your example, if you wanted to set object printer. So let's say I want to say object.printer, the printer key to some function that prints, right?
Yeah.
Console.log. So I can do that, right? And now in my object, I have this object printer function, and it's object.printer foo. That'll work, right? The value can be a function, but in the map, I can go crazy and I could say, let's set console.log as that key, right? So now I've got this function that's the key that points at the number 4. So I can say get console.log, and I get 4. The maps are just more flexible, and they'll let you use any object as a key. And in JavaScript, functions are object, arrays are objects, like anything can get set as the key. And so that can be interesting if you just have any sort of association between two types of things that you want to keep track of. Map gives you a little bit more flexibility. The other thing map is going to give you is the ability to say, map.size is not a function, map.size. Map.size.
Awesome.
You got 5 keys in there, where with an object, trying to
iterate through
in the object, it's a mess, right? It's like object.keys, and then you pass the object in, and then you say length, and if you don't do it that way, bad things happen, and there's, objects have like default properties. So this is just printing out, but there's that like, if you like loop through an object in a for loop, you end up getting like built-in default functions in the object. There's like kind of default keys that are set in there, and you can get complex. So it's a little messier with objects, which is why map exists. Because it's stripped down. It's just doing that mapping. Objects in JavaScript sort of do a lot of other things, and it's how classes are implemented. And so map is going to be like a little simpler.
What are the trade-offs of using map?
So for me, the trade-offs of using map are that like I really like this object syntax. I like being able to say object.tree equals green.
Gotcha.
So like that's kind of cool, and having to say map.set tree. I don't like that as much. So to me, it just looks a little messier sometimes. But it is super handy, and it does give you those other attributes, which is nice. So it's kind of, and I think, I'm going to make sure this. So you have like, map gives you this entries, keys, values. They're sort of built in. So I can say map.values, right? Super easy. And again, if you want to do that with the object, it's a mess.
Yeah.
And if you want to get this is another nice one. Entries. Map.entries will let you sort of like iterate through the pairs, right? So it like breaks your map out into just these like tuples, these pairs of like 2 things, key value, key value, key value, which is nice. So the trade-offs are sort of in there. Like for some things, the object syntax is nicer. But for other things, the map syntax is a lot nicer. Somebody like SJ, who's worked in JavaScript a lot more and a lot longer than I have, I notice SJ using maps a lot. Anytime SJ needs something that really is just a map, SJ will use map. They will not use objects. And SJ writes really beautiful code. So that sort of tells me I need to be using maps more. I think that I actually didn't know about maps until I started reading SJ's code. And I was like, map, what's that? I didn't know that was a thing. And so.
Yeah, it looks really cool. Thanks very much.
Yeah, no problem. All right, 2:02. I'm gonna call it there. We are overtime, but I am around. I am on Slack. Just hit me up. And I will, as soon as I got off here, I will go and find those videos and post links in the Phase 2 channel, even if that means I have to upload them first. And I will see you all around. Thanks for coming.